So the sine of 4/5, we can use this trig identity and plug in for x, change the denominators, and solve. If you think in terms of right triangle trigonometry, you could say that the sine of this angle 1 is opposite over hypotenuse. And you could also say that the cosine of angle 2 is equal to, effectively, O over H, because now it's adjacent. The thing about angles 1 and 2 is they add up to 90. So that's why we're going to use pi over 2. If in radians, converting it to degrees, this is the equivalent of 90. So it's like saying 90 minus the one angle, which is saying cosine of 90 minus the other angle. Same thing. So here's a right triangle, ABC. AC has a length of 12, angle A is 40, and B is a right angle. We can also figure out angle C. This is going to be 90 minus 40, or 180 minus everything else that's there, so that's going to be 50 degrees. Could we figure out the length of side AB? Well, if we said the cosine of 40 degrees, that's going to equal to AB over 12. So that's going to be 12 cos 40 is equal to AB. So we can figure out that one too. C. So here's PQR, there's R 38, P is 90, PQ is 70. Which of the following represents the length of side QR? So if we did the sine of 38, that's going to be opposite over hypotenuse, or 70 over QR. So QR is equal to 70 divided by sine 38. So if sine of x is 5 over 8, that's opposite over hypotenuse. So cosine of y is also 5 over 8. Because for cosine, with this angle, it's adjacent over hypotenuse. If you think about the unit circle, when we are at pi over 4, that is 1/4 of the way around to 180, we have this 45-degree triangle, and the coordinates are root 2 over 2, comma root 2 over 2. Since we were at 3 pi over 4, we keep going. There's 2 pi over 4, and over here is 3 pi over 4. And it's the same phenomenon of a 45-degree angle, and the coordinates are negative root 2 over 2, comma root 2 over 2. Since we want to know sine, we're looking at the y coordinate. So the answer is C. Here's our triangle ABC. C is the right angle. The sine of angle A is equal to opposite 3, hypotenuse 5. So what is cosine of B? Also 3/5. Because once we switch to this angle, 3 is adjacent and 5 is hypotenuse. Because these two triangles are similar, we're going to be comparing angle B and angle E. And the cosine of B here is going to be 12 over 13. So the same is true for E because the angles are congruent. It's the side lengths that are proportional. So if the sine of x is 0.6, I could think of that as opposite over hypotenuse and 6 over 10. That would give me 0.6. Then if I looked at the cosine of 6, now 6 is adjacent and 10 is still hypotenuse, so it's going to be 0.6 again. The number of radians in a 720-degree angle can be written as A times pi. So 720 degrees, each pi is 180. So 720 divided by 180, A is equal to 4. Here's triangle PQR with a right angle Q. If the sine of R is 4/5, that's opposite over hypotenuse, what is the value of tan of P? So opposite over adjacent. First we're going to use the Pythagorean theorem to figure out that this is 3, because 3 squared plus 4 squared is equal to 5 squared. That's a common Pythagorean triple. You might have remembered it. So the tangent of P is opposite over adjacent, so 3 over 4. In a right triangle, one angle measures x, where the sine of x is 4/5. So the cosine of 90 minus x, which is the cosine of this angle down here, is going to be adjacent over hypotenuse, which is the same thing, 4/5.